So geometric series, third term 6, fourth term 4. What was the first thing you did, Jaden? Good, because? Well, yep, you're told it's a geometric sequence, so what does that give you when you do? 4 divided by 6, good, it gives you the common ratio. Did everybody do that? Good, so the common ratio is 2/3. 2/3. Well, how did you write it? You wrote it as 0.66 like this. No, you don't want to do that, okay? It's not, it's because it's incorrect. The better, what you could write it, okay, even though I don't particularly like it, what would be a better way to write it rather than 0.66 with the whole kind of dots? Okay, if you do that, or the line on top, then fair enough, that's okay. But it's going to be easier when you come to work out, say, the sum, okay? Because that way you're not dealing with decimals. Fractions are a lot easier to deal with, okay? I promise. Alright, so we have to find the sum to infinity. You're given the formula. U1 over 1 minus R. U1, we don't know what U1 is actually. So how do you find that? Right, so, right, 6 divided by R. So 6 divided by 2/3, so that's the same as 6 multiplied by 3 over 2, that's 18 over 2, which is 9, so that is U2. U1 is going to be that number divided by 2/3, which is 9 multiplied by 3 over 2, which is, okay, cool, that is my first term. So that's just working backwards. We had, if I just write these numbers down, 4, 6, 9, 13.5. If I'm multiplying by 2/3 each time, it works. Okay, so 13.5 divided by 1 minus 2/3. 1 take away 2/3. 1/3. So if I'm dividing by 1/3, that is the same as multiplying by 3. Check it. $40.5. All good? Yep. Okay, so let's, they can make these a little bit more tricky, but let's go to some questions. We're going to do some practice this afternoon. That's not the right book. Where is the right book? Here. And if we have a look at page 162, these questions. Did anybody have any questions from the homework? All good? Okay.
Actually, yes.
Yeah.
For G, 4D, would you, the way that you add 0.14 recurring, 0.148 recurring plus 0.4 recurring, would it be 0.1 and then the 925 recurring?
Yeah, I would put the 0.148, 148, 148, put it into a fraction, do the same as 0.4 recurring into a fraction, and then just add the two fractions together. Okay. What did you do, Ari?
I added 0.14 to 0.4, both are recurring. And That's what I did. I did 148, 148, 148, 148, 148.
Yeah, just do them both separately into fractions.
Yes.
Yeah, and then add them. Okay.
Also, I have another question. It seems as if the answers on the back of the page were wrong. Some of them were wrong.
They could. I'll have a look now if you want. Determine whether or not a series has an infinite sum. How do we do that? Nope, not if it's going down. That is not going to work on the exam.
If it's ratios less than 1, but greater than negative 1.
Right, less than 1 or greater than negative 1. Okay, that is what you must say, okay? Okay, so we're working on these questions. You can grab yourself a book and we'll go from there, okay?
By like a finite sum.
So whether you can actually sum up this infinite sequence.
Okay.
So if it's got a finite sum, then it's equal to a particular value. Yep.
Okay. So that means like it's a ratio.
So it means it'll have a finite sum if your R value is in between this, okay? So it will have
If the R value isn't like the same, then it's not.
then it's not Yep.
Just 16 really for the last time in that sequence.
Yes.
Okay.
Like, does it just stop at 16,304?
Yep.
So, wait, are C and what is the difference between C and F and N?
So what did we write for, say, Y? What did we write for Y? Done that wrong.
A is infinite.
Yeah, like if you're asked to determine something, or because that was one of the things in that mock. Okay, you have to if you justify something, you can't just work out the calculation and then that's it. Okay, we can't just work out what R is and then just assume that the examiner knows. Okay, well that's bigger than -1 but less than 1, so it has to exist. Okay, you actually have to then state that fact. Okay, you could write it out like that, or you could just say, just do it as an inequality would be fine.
So you don't have to have,
Yep.
you just say it's finite.
You could say then it's has a finite sum.
So easy to get.
You need to have a little bit of a blurb, yeah. So for F, you've got, how do you work out R?
Divide. Wait, so would U1 be 1 and U2 be negative 0.2?
U1 is 1, yep, and U2 is negative 0.2.
So it would be.
You sure?
Oh, wait, never mind. If you can start at negative, as long as it's greater than negative.
So for F, yeah, it's just one is positive, one is negative, one is positive, one is negative. So that's just letting us know then that, okay, well, R is going to be negative because it's alternating.